All right, so in the next example, I want to talk about how to integrate powers of trig functions. So in this example, we're going to look at powers of cosine. We've got cosine to the power 1, cosine squared, and cosine cubed. There are different approaches you can take, that some of which use substitution, that will allow us to find integrals of these powers of trig functions. And you can extend this to sine, and you can also extend this further, to things like cosine to the fourth or cosine to the fifth or whatever. So here we go. So first of all, the integral of cosine is something we already know, right? That's negative sine. So that one, we'll take that one for granted with a plus c on the end. So for the higher powers of cosine, there's different strategies. I'm actually going to skip over cosine squared and move to cosine cubed because I think that one's a little easier. First thing I want to do is write cosine cubed as cosine squared times cosine. Right? First of all, that makes sense, right? It's 3 cosines multiplied together, so here's 2 of them, and here's 1 more. What we can do is we want to try to get the cosine x dx to be our du. And we know that if u is equal to sine of x, its derivative is cosine x, so then we could do a differential substitution with this cosine x dx. But we don't have sine of x. However, we do have cosine squared, right? So get your trig brain working here. Think about trig identities. What we can do is replace cosine squared via the Pythagorean identity with 1 minus sine squared, like that. And then we have that times cosine x dx. But now we have produced a function in here which has sine x in it. So what we can do is now let u equal sine x. Our du is, of course, then cosine of x times dx. So the portion over here is going to be du. And what we'll get is 1 minus u squared, right? Replacing sine x with u, 1 minus u squared. And then replacing all of this with the du. So now we have 1 minus u squared du. And this, we can just solve that integral with the anti-power rule. So this is going to be u minus 1/3 u cubed plus c. So now, undoing the substitution, we get sine x minus 1/3 sine cubed, 1/3 sine cubed of x plus constant. And that is our antiderivative. There we go. So, let's see. Robin, please be quiet. All right, sorry, that's my son. All right, so you can check that again. As always, you could take a derivative of this, and what you'll get is something that should simplify via some trig identities again to cosine cubed. All right. Okay, so now the cosine squared is a little bit more difficult. We're still going to approach this using a trigonometric identity, but not the Pythagorean identity. We have to use one of the little like lesser used, less common trig identities, which is the power reducing formula. So and one of the reasons power reducing formula is so useful is because it helps us with even powers of sine or cosine. So the formula is that cosine squared x is equal to 1 plus cosine of 2x all over 2. So applying that power reducing formula here to the integrand, we get that. Now that is something that we can integrate. So let's first distribute the division by 2, like this. And then we'll split up our integral. So we'll have an integral of 1/2 dx plus 1/2 times the integral of cosine of 2x dx. All right, the integral of 1/2 right here, that part is just 1/2 x. That part's not so bad. So the other one here, the second term, in order to integrate cosine of 2x, we can do a quick little u substitution with u equals 2x. Robin, you need to be quieter than that, okay? Sorry. And then du is going to be 2 times dx. Okay, Robin, you need to stop. Okay, so the 2 here is a problem. I'm sorry, I'm going to have to stop this and continue in the next video.